Hi, it's Robin. You know how in command line interfaces like MS-DOS or the Windows command prompt or Linux, you can pass parameters into a program from the command line? Like in DOS, you might go dir/p, or in Unix, you might go ls-l to add extra options to a directory. Or, you might want to grep for something in some file. So you might wonder if there's a way to do the same thing in C64 BASIC. So I've got my Commodore 128 here in 64 mode. We'll use 128 mode a little bit later. And I've got a short basic program here. Now you might wonder if there's a way to pass parameters into a Commodore BASIC program. And there actually is. This is just a very short example or a very simple example. So I've typed the run command and the program has figured out that the parameter I passed in was 123. You could pass, any string really. So you might wonder how this is possible. In C64 BASIC, the run command only allows one parameter, and that's the line number that you want to execute, like run line 10. And right now this program doesn't have a line 10, so it says undefined statement error. Well, there's one other thing that can follow a run command, and that, as you've seen, is a colon. Commodore BASIC just ignores everything after the run command, or after the colon. But it's possible for a BASIC program to detect what was typed in after there. It does take some peeking and poking. Okay, so we've already seen that the program's here, so let's look through it. The first line, P, just for pointer, I suppose, is pointing to memory location 514. Well, what's so special about that? Let's do this example again, 1, 2, 3, 4, 5. And I'll go into my Super Snapshot cartridge, into the machine language monitor, and we'll look at location 200 hex, which is 512 decimal. And we'll see some hex bytes here. So there's an 8A, and that is actually the token for the run instruction. 3A is a colon. You can see that here. And then there's the parameter I typed in plain text, PETSCI, 1, 2, 3, 4, 5. And those are the hex bytes for 1, 2, 3, 4, 5 in PETSCI. And the string is terminated with a 0. So this area of memory here is called the input buffer. Whatever you type in at the ready prompt in Commodore BASIC is then transferred here, and it's actually tokenized or compressed. And I went in depth with this in a previous video or two, so I'll put a link in the video description if you want to check that out in more detail. But what basically happens is that the parser runs through the text, and any keywords it recognizes it replaces with the equivalent token. Like I said, 8A is run, and 3A is the same colon. Numbers are generally left alone, as is a lot of text, but we'll get into that in a bit more detail. But the important thing is that whatever you typed in after the colon is still preserved and available in memory. And in this case, it's at location 202, which is 514 decimal. And if we go back to the basic program, you'll see that's where I've set the pointer. Now this is a very short example. We'll get into a more robust version later, so don't worry too much about that. This is just to demonstrate how it works. Then we have one more line of code where we peek that location and store it in V for value. If it's greater than 0, then we're going to build up a string, P string for parameter string, by adding the character value of whatever we peeked from memory, and then increment the pointer by 1 to point to the next location memory, and then go back to line 110. And it's just a loop that's going to copy the text out of memory and build up a string called pstring until we hit a 0, which is the terminator, and then we just simply print the parameter out here. So that's all it takes to pass parameters in. And we could very easily replace line 120 instead of printing out the parameter. We could try poking it into location 53280, which is the border color, and we'll convert the parameter into a numeric value. That's what this val function does here. And now if we run it, we can follow the colon with the color code, the number of what color we want the border to turn. So if I run it with 0, it'll turn the border color black. If I change it to 5, that's green. Some of you might think that's pretty cool. Some of you might be asking, why do that, or what's the point? Well, first of all, with retro computing, I don't think anybody has to justify why to do anything. If you don't like it, just don't do it. But you might be wondering, why not just use an input? After all, couldn't we just get rid of line 100? Line 110 we could replace with, say, input, p-string, and then we could just run the program, and you could type in that you want, say color 1, white. Well, sure, yeah, that does do the same thing, but a big reason to add command line parameters is so that you can have a default behavior that doesn't require any prompting, and you can optionally change the behavior of the program. Like, could you imagine if every time in DOS you typed in dir, if it actually prompted you what you want to do, and then you had to hit return again, or then type in your flags. It's a lot more convenient just to be able to type in the command and optionally add extra parameters to change its behavior. So you might want to add a help parameter that would print out a help screen only when needed. Or you could even do little Easter eggs like credits. Or if you saw my previous video about Livingston, I presume, the authors actually intended the same trick to be used to enable a cheat mode, but they goofed it up during the mastering process. I've got that first example back. There are some problems with it just because of how bare bones it is. If you just type run on its own, you'll sometimes get garbage parameters. And if you type other parameters, say you want to type in ABCDEF, watch what happens here. It says the parameter is ABC, and then it changed the cursor color. So do you know what's going on there? I was talking earlier about the tokenization. When you press return, Commodore BASIC scans the input. It changes run into its token. It's also gone ahead and changed DEF is actually a basic keyword to define a function. And so that has been turned into a token. And then when it's printed out, it interprets it as the code to change the color. We can look just out of curiosity. What is that? Yeah, so here's the ABC, and the DEF got condensed down to 9.6, the token for DEF, and then there's the end of the line. And 9.6 just happens to be the screen code to change the cursor color to whatever that is, I think light red. So how can we avoid that tokenization? Well, there's two ways. If you type the rem command, everything after the rem command doesn't get tokenized. But you'll notice the spaces here, and in fact, I think there's another problem. This is just an example. We'll fix this up better in a moment. And the other way of avoiding tokenization is to type a quote before, and that also avoids the tokenization. But again, now we've got a problem of either spaces or quotation marks in our input parameter. Okay, so what I've done is made up a new example here. This is just a more robust checking routine for those of you who care about such things. So if you run it on its own, you just get back no parameter from line 150. And if you run it with just a colon, you also get no parameter. And if you put the quotation mark, it'll strip the quotation mark out. And same with if you do a rem, it'll strip out the rem and a leading white spaces. And just to quickly look through that, instead we're going to start location 513. I think we're guaranteed that the run token will always be at 512. And then this line 110 just scans looking for either a null termination or 58, which is the colon. So it looks either for the end of the line or a colon. Then it checks the special case. If it is the end of the line, that jumps ahead to 150 with a null parameter string, meaning there is no parameter. Otherwise, it's going to scan the line again, looking for these codes. 143 is the token for rem. 34 is a quote. And 32 is leading space. So again, it just scans past any of those things. And then finally, line 140 builds up the parameter string as before. Okay, so that's just a little bit more of a robust version in case you want to try that. That's going to be on the D64. I've included example 2. So what I've done is made just a bit more of a full-featured example. It's still fairly useless, but just to give you an example of what can be done with this, if you just run border on its own, then it detects that you didn't put in any parameter and tells you the usage is to type it in this way, run rem color, where the valid colors are, and it lists them all. So try that. You can run and run black, and the border color changes to black. Run cyan. Now cyan. Run light green. And run dark gray. And if we do a false color, like nothing, it detects that. It's an invalid color, and again tells you what the valid parameters are. Okay, I'm sure this could be improved greatly. Again, it's just an example. We'll walk through it. Okay, up to line 140 is exactly the same as the more robust version of the parameter scanner that I just showed you. Then on line 50, we just check if there's no parameter. It's going to go sub 400, which is the help routine, and then end. Line 160 reads all the data statements. I'm going to list that again, so you can see down to the bottom. So it's going to sequentially read these data statements, black, and if a string isn't equal to error, which is the last one, checking for the end of the data statements, and the typed in parameter doesn't match, then we're going to increment this counter X and loop back to line 160. So it's just going to go through, and it's either going to finish when it reaches the end of the file, error, and it's going to be counting up actually the color number just because we have these in the same order as the VIC chip recognizes these colors. Once it's done scanning, either it's succeeded or failed, we check, did the user type in help? If so, show the help file and end. If it hit error, that's the end of the list, then it prints an extra invalid color and then prints the help file and ends. Otherwise, it just pokes the index that we came up to between 0 and 15 for the matching color down here, and it just pokes into the border color and again ends. Starting at line 400 is that little help routine, which just gives the help message and prints out all the colors. And then here's the data statements for all the colors, again arranged in the same order, where black is color 0, white is color 1, red is color 2, cyan is 3, and so on, all the way up to light gray, which is 15. And I do want to just point out one thing. All those examples I showed, like run brown, even though my usage example has rem, and actually you can use the quote too, here's something, run orange, and it says it's an invalid color. Well, can you guess why orange, even though it's listed right here, why is that one invalid? But if I type in run and either put a quote in front, there it worked. Or if I also do a rem first for orange, that works. But just orange on its own creates an invalid color. And did you guess? It's because OR is a keyword, and that's getting tokenized. We should be able to look at the Super Snapshot monitor. Yep, there it is. Run : and you can see the A and G, the last four letters of orange, have survived, but there's now this B0, and that's the token for the keyword OR, or. So that's why it's necessary, at least sometimes, to provide that ability to put quotes or a rem in. Okay, if you're still unimpressed with this, that is fine. I'm going to try one more time to impress you. I'm going to remove my Super Snapshot cartridge, which forces the 128 into C64 mode. And I'm going to put in instead my Mach 128 cartridge, which supports 128 mode. I just like using it because it gives me wedge commands, so I can get back into my folder on my SD card, changing directory to temp.d64. You see right now I don't have any program loaded. Back arrow D disables the fast loader on the Mach 128, which allows the SD card to load without crashing. Otherwise, the fast load protocol isn't compatible with that, and it'll just freeze up. Okay, so back arrow D. Okay, now Commodore 128 BASIC has a feature where you can have a string parameter for run, and you can type in a file name, and it will load and run that program. I've already got one called temprint on the disk here. And there we go. It's able to load and run temprint. The parameter passing trick that we've been talking about today works with this. So this is kind of cool. You can run border, and then we can type in whatever, blue, and it will run and execute, and now the border is blue. So we can run temprint again, and we can go back here and run, and we'll make the border, whatever, white again. And there it is. So this ability moves us even closer to kind of a true command line, where in just one single command, we can load and execute a program with parameters, all in a single instruction. So I think that's pretty neat, and that's something that the 128 BASIC supports. All right, back to C64 mode for a bit of assembly language. And for the fans of assembly language, I'll just give a brief example of how this sort of thing can be implemented in assembly in C64 mode. Okay, just starting up Turbo Macro Pro here, 32768. And we'll load my example ML4, I called it. Back arrow 3 to assemble. Back arrow 1 to quit to basic. Okay, so here's our assembly language program. And this one, I've just had it take a single 16-bit integer as a parameter. So whatever, 1, 2, 3, 4. And it's smart enough to know that if you exceed a 16-bit value, it'll actually give you an illegal quantity error. And if you otherwise mess around with it too much, it'll give you a syntax error and so on. I mean, it's not the best parser. This is just a simple example, but at least you get a syntax error. It doesn't crash or anything, because it expects run, : and then the single 16-bit integer. Let's go back into Turbo Macro Pro. I'll just walk us through this. So I made this into an executable stub. I think I've shown this before, But basically, if you assemble to 0801, that's the start of basic memory. And if you put these particular bytes into memory, a 16-bit word of 080B, which is just a link ahead to the 0 byte, which is the end of the basic program. This is just simulating a basic program in hex. Not simulating, but recreating what's in C64 basic memory, but we're doing it manually instead of the interpreter. And then you put a word which represents the line number, and it's tradition just to use the year. You can do whatever you want there. And then you put in 9E, which is the token for the sys command, and then the text for the sys address, and you should do 2061, unless you know what you're doing. And then follow that with 30 bytes, which indicates the end of the basic program. The end effect is that the program, even though it's machine language, will be runnable, and it'll just be a single sys command which executes the machine language which follows. Okay, so that's what that is. We call that a basic header or basic stub. Then next here, we're going to preserve text pointer. Here in memory, at locations 7A and 7B is some self-modifying code, and this is at the heart of the basic interpreter. So I'm not going to look at that in depth today because I've already covered that in another video. Again, there'll be a link in the video description to that. But essentially, this is a 16-bit pointer to the next command that's going to be interpreted. And when you're executing a basic program, normally that's pointing into your basic code. And this is almost like that, the finger that points into your code wherever it's currently executing as you go through all the lines of code. We're going to be modifying that, so we're just going to save that temporarily in these free locations FA and FB, which are available for our use. So normally text pointer points into program, but when you're in immediate mode, it actually points into the line buffer at 0200. So we're going to manually kind of hack this to point it into our text buffer at location 0202. 0202 is the same as that 514 decimal that our previous example in BASIC was using. So we're just going to be pointing the BASIC interpreter to look at the line buffer of what we typed in. And now all we have to do is call this BASIC routine, which evaluates the expression that text pointer is pointing at, which is our parameter. And whatever is being evaluated is put in the floating point accumulator. And then this routine at B7F7 converts into a 16-bit integer. I believe I've shown these routines used before. Oh yes, in that sysparams episode. Again, I'll put a link in the video description. And the important thing here is that this routine converts the floating point value into a 16-bit value, where the A register holds the high byte and the Y the low. And just for this first example, we just want to print this out, which also expects the high byte in the accumulator, but expects the low byte in the X register. So we have to move the output from this routine, which is in Y, into X. And unfortunately, the 6502 does not have a transfer Y to X command. So instead, maybe there's a better way of doing this, but we'll push on the stack, transfer Y to A, transfer A back to X, and pull the value on the stack back into the accumulator. And then we will call this BDCD, which prints a 16-bit value. This is another basic routine that we're borrowing for our own purposes. And then we're just going to restore the text pointer that we stashed away. You don't necessarily have to do that, but it's what allows our basic program to be better behaved, where I showed you those, gave the syntax error and correctly told you the line number. It would not be as well behaved if we did not restore text pointer afterwards. If we want to convert this program into a simple version of the border color program, still all machine language, we can get rid of all this pushing and popping and so on, and we don't need to print the value anymore. Instead, we've got the low byte of the value we read from the parameter in the Y register, And we can just store that in D020, which is the border color. Back arrow 3 to assemble, back arrow 1 to quit to basic. Again, we'll list it. If we run it with 5, should turn the border green. There we go. 15 should be light gray. So again, that's just a simple example. You could instead pass a string in and process that and everything. But I just wanted to present a tidy little example for your own starting point if you want to experiment with this. Okay, I hope you found that interesting. I really enjoy all these little kind of hacks and ways we can adapt BASIC quite easily to add extra features to it. Okay, thanks to my patrons for their support. Thank you for watching, and we'll talk to you next time.
No house keys, but hey, you figured you'd go anyway. In your car for the first time in a month. It started fine, and off you drove. Through the fresh snow, an enjoyable ride. Pulled up to Rainco's and went inside.